Welcome to Day 2 notes on Intro to Graph Parts and Vocab. And if you take a look first at what we have going on here, it's very similar to what we did for notes yesterday and what you practiced for homework. So if we had any struggles with last night's, the previous night's homework, this is definitely going to help. And again, as always, remember, you can always reach out to me on Remind and I can help you there as well. So let's get right into our directions. It says, for each example, describe the role of A, determine the vertex, axis of symmetry, shifts, domain, range, and y-intercept. So let's do that. To decide the role of A, first we have to say, what is A? So what is A? What do you say A is? I can help myself out if I need to, and above here, write my general vertex form, because it'll help me to, the more we write it, first of all, the more we'll remember it, and it'll be like, oh, check it out, A is right there. So A equals 7 halves. So we have to make two choices. Does this tell me if it opens up or down, and is it normal, wide, or narrow? First off, I see it's a positive A, so I know that that opens up. Be careful what we do next, because many are like, oh, it's a fraction. It is a fraction, but what does 7 halves equal? Well, 7 halves equals 3.5. So make a note of that so we understand what we're about to say next. So yes, it's a fraction, but its value is greater than 1. So if A is greater than 1, is it normal, wide, or narrow? And I'm hoping we're all saying to ourselves, more narrow. We're asked for the vertex, and this is given to us in vertex form, which is really nice because we have no work. We just have to accurately identify H, comma, K. So coming up to where I wrote my general form above, that's really helpful to me because I can be like, huh, check it out, here's H. This positive sign, though, should catch our attention. In the last lesson, we discussed how the original is a negative, a built-in negative. So if I see a plus 1, what kind of 1 was plugged in for H? And the answer is a negative 1. That's what caused the original negative to turn into a positive. It's the same as saying x minus a negative 1. Minus minus turned into a plus. So that's H. K we can take straight from the end over there. So that's negative 1, comma 3. Now we're asked to say, is this a maximum or is this a minimum? So before we go any farther, I think it's helpful to get ourselves a picture. And we started to informally practice sketching in the last lesson, and now we're actually asked for the sketch. So let's plot the vertex first. Negative 1, comma 3 will be left 1, up 3. So we went left 1 and then up 3. How do I know how to sketch? Well, I'm going to come over here and I'm going to look at what I know about A. I know that A is positive, so it's going to open up, and my graph should be more narrow. In the future, we'll get to more accurate sketching, but right now this is just a rough sketch. Visibly make that graph look more narrow. Now that we have the visual here, oh, and we can label, by the way. Here's our vertex, negative 1, 3. Now that we have our picture, we can decide, do we have a maximum or a minimum? If we're having a struggle making a decision, you can make a note up here. If it opens down, that's a maximum. If it opens up, That's a minimum. So if I look at this graph, it's opening up, which means negative 1 comma 3 is a minimum. And logically, that kind of also makes sense because this is literally the minimum point, the smallest ordered pair, the smallest x value and the smallest y value. Where does axis of symmetry come from? Axis of symmetry comes from the x value of the vertex, and the more you write x equals x sub v, the more it'll help it stay. So that's why I continue to kind of make little notes, like the vertex is h comma k. The axis of symmetry comes from the x value of the vertex. The more we write it, the more our brains will hold on to it. So I look at the x value of the vertex right here and I see that it's negative 1. So right away I know my axis of symmetry will be x equals negative 1. And again, that's going to be that invisible line, that's why it's dotted, that cuts the parabola directly in half. Our shifts come from where? Shifts come from the x value of the vertex and the y value of the vertex. So let's say what these are. X sub v is negative 1, and the y value of the vertex, y sub v, is 3. On your own, please try writing down what these shifts mean. For negative 1, I'm hoping we wrote shift left 1, and for the y value 3, shift up 3. Please don't draw this, but I want you to take a look right here. My original y equals x squared is right here. So the original vertex 0, 0 was shifted left 1 and then up 3. That's how it got right there. So again, the vertex is the boss when it comes to shifts, left and right, and then up or down. The domain, what's my domain? Coming from the left, I hit an arrow. Coming from the right, I hit an arrow. Domain is all real numbers. Range, please take a second and try the range on your own. So for the range, when I come in from the bottom, I hit a 3. So coming in from the bottom, 3 is the smallest possible y value, and then the graph continues from there. So 3 comma. Coming in from the top, I hit arrows, so that's 3 comma infinity. Last but not least, we are asked for the y-intercept. Do I get the y-intercept for free from vertex form? Yes or no? The answer is no. We need to calculate f of 0. So let's do that. Let me see if I can, just for a moment, keep the equation and what I'm about to write on the same line, and then I'll move it up. So f of 0 will equal 7/2 times 0 plus 1 squared plus 3. So I literally, it's pretty messy, 7/2. I literally took the equation that it gave me. This is going to bother me. Let me just fix it. That's better. Literally take the equation it gave you and plug in 0. So I don't want to get too crowded over here. I'm not sure where you are for spacing. So you can either kind of draw an arrow to keep doing the work, or I have the ability to move it, so I'm just going to move mine. But you can just draw an arrow. So let's calculate f of 0. Parentheses first, right? PEMDAS. So 0 plus 1 on the inside is 1. Next comes exponents. 1 squared is just 1, so this just becomes 7/2 plus 3. Half of 7 is 3.5. I add 3 to that, and I get 6.5. We plugged in 0, and we got out 6.5, so my y-intercept will be 0, 6.5. So number 1 was vertex form. Take a look at number 2. What form is number 2 in? It is standard. And if we want to do what we did before and put the general form, we can. It's ax squared plus bx plus c. On your own, please state what is a and what 2 pieces of information do we get from that a value. So I'm hoping we said a equals -2, and that a negative a tells me that this opens down. Then, ignoring the negative, just looking at the number, I see a equals 2. So if you wanted to use the absolute value bars now, you could. Meaning we're taking the absolute value of that number and we get 2. That is greater than 1, which tells us it's going to be more narrow. The vertex is not given to us because we have standard form. So recall, when we have standard form, what's that little equation to calculate the x value of the vertex? -b over 2a. So let's use, I'm going to commit to maybe just this middle piece. We're going to still have some writing to do here, and I don't want to crowd the sketch. So kind of use the space here in the middle. I'm going to label my work vertex, so I'm very clear with what I'm about to calculate. It always helps to write the general equation first, because it'll help us to remember that it is -b over 2a. It could also help you to commit to what is a and what is b. So when I come up here, a is -2 and b is -8. So on your own, please take a second and please work on what is -b over 2a using a is -2 and b is -8. You can check with a neighbor when you're finished. What do you get for the x value of the vertex? So let's see how you did. The negative is still there in the front. Plugging in a -8 completes the numerator. And then in the denominator, 2 times -2. That's going to equal 8 divided by -4, which is -2. Hopefully we match. If we don't, please check for a sign error maybe. But this should be pretty straightforward, I hope. With practice, we'll get really good at it. Now that's only half of it, right? Because if that's only the x value of the vertex. So how do I go find this y value? Well, we've got -2, so now let's plug it in. So we're going to do f of -2 equals, and I'm going to use this as my model, -2 times -2 squared minus 8 times -2 minus 15. So I'm going to be working through the algebra here. I'd ask that as I'm working, you're working too, and then we'll see if we match. If you need a hint, you can look up real quick and keep watching. Otherwise, please give it a try on your own. So I got -7 as an answer. Do we match? Discussing the algebra real quick, I'm going to square -2 first and I get a +4. -8 times -2 is a +16 and I bring down the -15. This results in -8 plus 16 minus 15. -8 plus 16 is a +8 minus 15 and I get -7. To decide if this is a max or min, now would kind of maybe be a good time for us to create our sketch. And the reason I was able to set up my axes like this right away is that I know where my vertex is. I know that I'm going to go left 2 and down 7. How do I know how to sketch from here? Well, to move forward, we'll take a look at A. A tells us that it's going to open down and that it's more narrow. So I'm going to sketch a parabola that is opening down and is visibly more narrow. I can label my vertex -2, -7. So looking at this graph, is this creating a max or a min? I'm hoping we're saying maximum, and you would be right, because it's literally the highest, the largest XY ordered pair on the graph. So it is the maximum. Where does the axis of symmetry come from? Give it a try. What is the axis of symmetry? And please also sketch it on the graph. You can look at the one we just did before, look at yesterday, the previous class's notes. What is the axis of symmetry? Axis of symmetry comes from the x value of the vertex. So I see it right here, it's -2. And we can plot that invisible dotted line at x equals -2 that literally cuts the parabola directly in half. Shifts comes next. Please give the shifts a try. My hint is pay attention to the vertex. So use the value of the vertex to discuss whether or not this is shifting left or right, up or down. Take a minute and give that a try. Check in with a neighbor if you're not sure. Maybe they can help you out. Look at your notes. So as we've discussed before, shifts come from the x value and y value of the vertex. So looking at the x value, it's at -2, and the y value is -7. -2 for the x value tells me that this has been shifted left 2. And then a -7 for the y value tells me it's been shifted down 7. And again, if I keep in mind where my original vertex was at 0, 0, we have shifted left 2, down 7 to get to this new vertex. Please work on domain, range, and y-intercept on your own, and then we will compare answers. So domain, range, and y-intercept on your own. The domain will always be all real numbers. Let's talk about range. Coming in from the bottom, I hit arrows, so that's -infinity. Coming in from the top, I ask myself, what's the largest y value that this parabola has, and it will be the y value of the vertex. So it's going to be negative infinity, comma, negative 7 with a bracket because it can equal negative 7. Y-intercept takes no work because we get it for free since we have standard form. So to make that super clear, I'm just going to recopy over the original function. So remember, when we have standard form, the c value automatically is my y-intercept. And again, just to show you why that works, so here's the y. Just like with vertex form, we can evaluate g of 0. So we're going to plug in 0 wherever we see x. But take a look at what happens. 0 squared is 0. Anything times 0 is gone. It's 0. And then here again, 8 times 0 is 0. So it leaves the c value behind. So if you forget this, no worries. Still go ahead and calculate g of 0 and you will get the right answer. That completes our examples for vertex form and standard form, but with a much stronger connection to our graphing, our quick sketches. And let's now get a little deeper into this concept of vertex. At the top of the previous page we had sketched. Let's resketch. So again, positive A tells me it's going to open up. Negative A, down. What I would like you to do is commit to these vertexes. Is this a minimum or a maximum? And is this a minimum or a maximum? Go ahead and write it in big letters, in pencil, just in case. Positive A tells me that this is going to be a minimum. Because it's literally the smallest xy ordered pair on the entire parabola. Whereas over here, if it's opening down, this will be a maximum. Because this xy ordered pair is literally the largest ordered pair on the parabola. We have a set of practice questions here. The directions say determine the vertex of the quadratic function and state whether it is a maximum or minimum point. And if we take a survey real quick of the whole page, we have numbers 3 through 6 that are in standard form. And then below here we've got vertex form. So these boxes are actually meant to help us recall what to do. So for standard form, we are going to calculate the x value of the vertex by calculating negative b divided by 2a. Then evaluate f of that value to find the y value of the vertex. For 3 through 6, I'm actually only going to do 2 of these, and you'll have time to practice with a neighbor. I will do number 4 and number 5. So let's take a look at number 4. We're just asked to find the vertex. So it's going to be x value of the vertex equals negative b over 2a. I see that I have a negative 5, so I'm going to very carefully make sure that I'm substituting in a negative 5, realizing that that negative here creates negative 5. And then in the denominator, I have 2 times negative 1. So be very careful with your signs. Negative negative 5 is a positive 5. 2 times negative 1 is a negative 2. So the x value of the vertex here is half of 5, which is 2.5. So it is definitely possible to get decimal values. If you haven't taken out your calculator yet, you're going to need it, because this is only half of it, right? This is only the x value of the vertex. We also need to find the y value. So to do that, we will evaluate f of negative 2.5. That will be negative, and then in parentheses, negative 2.5 squared minus 5 times negative 2.5 plus 7. I know that a negative squared is positive, so in my calculator I really just need to take care of 2.5 squared, which gets us 6.25. This negative is still up front. So this negative 2.5 all squared got us a positive 6.25, but that negative is still up front. Next, let's take a look at negative 5 times negative 2.5 in our calculators. And we should be getting a positive 12.5. Bring down the plus 7. Negative 6.25 plus 12.5. What do you get in your calculator? We get positive 6.25 plus 7 is 13.25. So my vertex is at negative 2.5, comma, 13.25. But I still need to answer one more question. It says, determine if it's a max or a min. So looking at A, does this parabola open up or down? And I'm hoping we're all saying down, and I would agree. So if this is opening down, it means that this vertex is a maximum. And I'll abbreviate just using max. Taking a look at number 5, the process repeats. X value of the vertex equals negative b divided by 2a. So that will be negative what up top? Well, looking here, 9 is b, so negative 9. Notice I didn't have to use parentheses because I'm plugging in a positive 9 here. And then in the denominator we have 2 times a. What's a? A here is 1/2, so I can plug that in. And don't be intimidated by the fraction. No worries about it. We have negative 9 in the numerator. Let's think. What is 2 times 1/2? 2 times 1/2, or half of 2, is 1. So we get negative 9 as the result. Again, we're only halfway done because we need to now calculate the y value of the vertex by calculating f of negative 9. So that's going to be 1/2 negative 9 squared plus 9 times negative 9 plus 4. Applying our PEMDAS knowledge, what's going to come first? I'm hoping we're all saying exponents, and I would agree with you. 9 times negative 9 is a negative 81. Half of 81, or in your calculator you can do 81 times 0.5, gets us 40.5, and then everything else can come down. That line right there I could type directly into my calculator. And let's see what you get when you do that. You should be getting negative 36.5. So my vertex is at negative 9, negative 36.5. And I have to decide, does this create a maximum or a minimum? What do you say? Well, to know that for number 4, we committed to the fact that it was a negative a, so it opened down. Here, do we have a positive or negative a? Here, looking at a is 1/2. That is a positive value, which tells me that this parabola will open up, creating a min. Creates a minimum. So I will be leaving 3 and 6 for you to do in a minute. Let's look at our second type of quadratic, which here is vertex form. And notice, very little space to write and very little space to work, because vertex form is awesome. In general, we have f of x equals a times x minus h all squared plus k. My vertex I get for free. I need to identify h and k. We need to remember, though, h has a built-in negative. H has a built-in negative. This says built-in. So let's take a look at 2 of these together, especially focusing on this reminder that h has a built-in negative. I will be doing number 7 with you and number 8. So looking at h comma k, I know I'm going to pay attention to the 6 right here, the positive 6, and the negative 11. Number 7, this note applies. Remember, it's got a built-in negative. So you could actually see that as x minus a negative 6. So if I look here, it's supposed to be x minus h, right? So x minus h, it's a negative 6 that got plugged in. So my vertex is going to be negative 6, comma, and I look at the k value on the outside, negative 11. To determine if this is a max or a min, I have to say, or decide, what does a tell me? A tells me that that is a positive a, which means it opens up, and 7 is a minimum. By 7, I mean the vertex for 7. Negative 6 comma negative 11, which is right here, creates a minimum point. Finally, number 8. Again, I've got vertex form, so I can just pay attention to h and k. Remember, we have a built-in negative, so a positive 8 got plugged in here for this to stay x minus 8. So my vertex will be 8 comma negative 2. And all I need to do is decide, what does a tell me, so that I know if this is a min or a max. Well, I see that I've got a negative a, which means the parabola will open down, creating a max, a maximum value. With the remaining time, please work on number 3, number 6, and then both 9 and 10 down here. So there's 4 for you to work on. And as always, please shoot me any questions on Remind. If you are watching this right now in class, it means that you have approximately 10 minutes to work on these 4 questions with a classmate, which is awesome. So please decide who you're going to work with and get to work on 3, 6, 9, and 10. And pay attention to the assigned homework for tonight, which will be directly connected to the notes we just took. I'm not sure if I printed that next page. I didn't. It's going to be the next page or 2 in your workbook. So the ones marked here as you try are classwork, not homework. So go ahead and use your time to practice, and homework will be page 16 and I believe 17. But I will post that to the website so there's no confusion. Good job, and let's get to work with a partner.